Today we're going to be dealing with combinations of functions, compositions of functions, and their domains and the difference quotient. We're going to start out with just using your previous math class knowledge. Just kind of go, what is a constant function, a linear function, and quadratic? So constant function, what does the graph of the function look like? We would say this looks like a horizontal line. Since it's a horizontal line, what is the domain of this function? It would go from negative infinity to infinity. A linear function's either going to go up or down. So what's the domain of this? Negative infinity to infinity. Quadratic function's either going to go up or down. Same thing. What is the domain? Negative infinity to infinity. So all of those are going to be negative infinity to infinity for the domain. So now when we go beyond that, the domain of a function is a set of x values for which there is also a y value. So if we're looking at this equation right here and we're trying to find f of negative 2, this means we would go negative 2 squared plus negative 2 minus 6 all over negative 2 squared minus 4. If we work that out, I'm going to kind of put it over here. We get 4 minus 2 minus 6 all over 4 minus 4, which means there's no solution because we end up getting negative 4 over 0, and there can't be a 0 in the denominator. F of negative 1, if we were to plug that in, negative 1 squared is 1 minus 1 minus 6 over negative 1 squared, 1 minus 4. So we end up getting negative 6 over negative 3, which is 2. Now, what conclusion can you make about the domain of the function based upon these two computations? What do we know about it? Since we can't have a 0 in the denominator, it means that x squared minus 4 cannot equal 0. If we solve that, we get x cannot equal plus or minus 2. Then we look at this next one. G of negative 4 would mean that we would go 5 minus negative 4, which becomes square root of 9, which is 3. Then if we do g of 9, we get square root of 5 minus 9. We get square root of negative 4. Now, without dealing with imaginary numbers, because we're talking about real numbers now, there's no solution. So what conclusion can we have is that we can't take the square root of a negative, which means square root of 5 minus x must be greater than or equal to 0. If we square both sides, we get 5 minus x is greater than or equal to 0. And then we end up getting x is less than or equal to 5. That would be my domain of that one. Now, if we were to put that in interval notation, that would be negative infinity to 5 bracket. We go to the next one. It's a cube. Can we take a plus, or can we take a cube root of a negative? Yes. So if we plug this in, cube root of negative 11 plus 3 equals the cube root of negative 8, which is negative 2. If we do the cube root of 5 plus 3, we get the cube root of 8, which equals 2. So are there any restrictions on this one? No, because we can take the cube root of a negative and we can take a cube root of a positive. So for this one, our domain is just negative infinity to infinity. So basically it comes down to this. When you're trying to find the domain, the only time there are restrictions, if it is a fraction, you're going to set the denominator not equal to 0 because you can't have a 0 in the denominator. If it's an even root, you're going to set the quantity under the radical to be greater than or equal to 0, just like we did up above. If it's got an even root in the denominator, then you're just going to set it greater than 0, because you can't have it equal to 0 if it's in the denominator. So now we're going to go to these next problems. Find the domain of each function. Use interval notation to express your answer. So in terms of a, what is that? That is a rational expression, which means we cannot have a denominator of 0. So I'm going to set x squared minus 49 cannot equal 0. If we solve that, we get x cannot equal plus or minus 7. Now, to put that in interval notation, we start at negative infinity, we go to negative 7, union, start at negative 7, go to 7, union, 7 to infinity. For b, we have a square root. So what do we know about a square root? We're going to set that. Our restrictions are going to be what makes it, this has to be greater than or equal to 0. If we solve that, we get x is greater than or equal to 3. So if we put that in interval notation, that means it starts at 3, goes to infinity. It's a bracket because it's got the equal sign. Are there any restrictions on a quadratic? No. So this one would just be negative infinity to infinity. What are the restrictions on this? Can't divide by a 0, and a root has to be greater than 0. So x plus 2 is greater than 0. Since it's in the denominator, there's no equal sign, which means x is greater than negative 2. So if we do this as interval, it's negative infinity to negative 2, union, negative 2 to infinity. And that is wrong, so ignore what I just said there. There's no union in this one. Don't know what I was thinking. So for this one, it's just greater than negative 2, so it's parentheses because it's not equal to, and it's just negative 2 to infinity. Go on to the next. Now we're going to be dealing with compositions of functions. So compositions of functions. These are all the different formulas that go on with it. The sum formula, difference formula, product, and the quotient. So if we're dealing with this first one, what does this mean right here? This means what is f of 5 minus g of 5. So we take and plug in 5 for our f function, and we get 3 times 5 squared minus 2 times 5 plus 1 minus this whole function, 4 times 5 minus 1. So 5 squared is 25 times 3, 75, minus 10 plus 1. 20 minus 1 is 19, so this becomes minus 19. If we work that out, we should get 47. Then we go to the next one. This just means f of x plus g of x. No number to plug into x. No number to plug into x. So if we look at that, we're just going to combine like terms. So this would be 3x squared plus 2x, and then the positive 1, negative 1 cancel each other out. And that's what we would get for that one. This next one just means f of x over g of x. So if we write this out, we get 3x squared minus 2x plus 1 over 4x minus 1. Then we can look at, okay, can this be factored? No, it cannot. So are there any restrictions on this? Yes. You can't have a 0 in the denominator, so x cannot equal 1/4. Now we're going to go on to the next one, which is going to deal with roots. So if I look at this, I'm going to go f of x plus g of x, which gives me root x minus 3 plus root x plus 1. Now for this one, different roots, so I cannot combine them. That would be my solution for that. But now it wants a domain. So in order to get the domain, I'm going to find out the domain of each of these. So if x minus 3 is greater than or equal to 0, I get x is greater than or equal to 3. If x plus 1 is greater than or equal to 1, I get x is greater than or equal to negative 1. If I look at those on the number line, here's -1, here's 3. This one of them would look like that. The other one would look like that. Then you have to look at where do they intersect, and they intersect all over here, which means what's my solution for my domain? It is from 3 to infinity. There's my domain. So it has to be where the two intersect because it's got to be able to satisfy both. And if I take a -1 here, I'm going to take the root of a -4, which is not, it's an imaginary number. It's not going to be a real number. So now we're going to go to compositions of functions. So how this is read, this right here is saying f of g of x. That's what that's read. That little open circle means of. So when I go down here, I'm going to look at what's the domain. The domain is all x such that x is in the domain of g, so it's got to satisfy the g of x, and then whatever I get for that has to be in the domain of f. So if I go to this problem down here, this is what this is saying, f of g of x. That's how you write it, which means I'm going to plug my g equation into my f equation. So I'm going to take that and I'm going to plug it into my f. So this becomes 7 times 2x squared minus 9 plus 1. Then I'm going to simplify it, and I get 14x squared minus 63 plus 1, which simplifies to 14x squared minus 62. Now, domain. What's my domain of g of x? All real numbers. What's my domain of that? All real numbers. So if I was to ask you for the domain, it would just be -infinity to infinity. Then I go to the next one. This is read as g of f of x, which means I'm going to plug my f equation into my g equation. So then I go 2 times 7x plus 1 squared minus 9, which gives me 2 times 49x squared plus 14x plus 1, no more square, minus 9, which gives me 98x squared plus 28x plus 2 minus 9. If I simplify that, I get 98x squared plus 28x minus 7. Now, for my domain, I look at my f of x first. What's the domain of that? -infinity to infinity. What's the domain of that? -infinity to infinity. So my domain is just -infinity to infinity. Even though it's not asking for that, I wanted to make sure we paid attention to what domains were. Going to flip it over to the back. So now, this one right here is stating f of x, which means I'm going to plug my f equation into my f equation. So I take 7 times 7x plus 1 plus 1. I get 49x plus 7 plus 1, which gives me 49x plus 8. What's the domain? All reals, all reals. So -infinity to infinity. Now we go to the next one. This means f of g of -1. So first thing I have to do is I have to do g of -1. So g of -1 would be 2 times -1 squared minus 9, which equals 2 minus 9, which equals -7. Once I've got that, I'm going to do f of -7. So f of -7 would be 7 times -7 plus 1, -49 plus 1, which equals -48. So my final answer is -48. Now we're going to be dealing with stuff that does have restrictions. So far, none of these have restrictions because they were either linear or they were quadratic. And those are just all real numbers. So now we go to the next problem, example 5. So f of g of x. So f of g of x. I'm just going to write it. So I'm going to take my g equation, plug it into my f. So then I get 6 over x over 6 over x plus 5. I'm going to multiply by my LCD, so x over x. And I get 6 over 6 plus 5x. So there's my answer to the equation, but I have restrictions on my domain. So if we go down to where it says what are the restrictions on the domain, we look at, okay, g, what are my restrictions on g? X. So x cannot equal 0. Then we look at my restrictions on my final answer. What's the restrictions there? X cannot equal negative 6/5. So if I put that in interval notation, that means I'm from negative infinity to negative 6/5 union, negative 6/5 to 0, union, 0 to infinity. So it doesn't equal negative 6/5 and it doesn't equal 0. So now, the next part we're going to be doing is decompositions of functions. Okay? And there are multiple answers for this. You're basically pulling it apart. What two things would you have that is going to equal h of x? So it's asking you, remember, g is inside. So what's inside here? Because this is what it's wanting me to figure out. So what's inside here is 2x minus 5. If I take that and plug it into x to the third, will I get h of x? Yes. If I take this, plug it in here, will I get h of x? Yes. Is that the only answer? No, that's just the most common. Then we go to the next one. What's inside? 3x minus 4. What's outside? Absolute value of x. If I take that, plug it in there, will I get h of x? Yep, that's what it means by decompositions of functions. So now we're going to deal with a graph, and we're going to write out what each of these things means in order to do this. So this right here means f of negative 2 plus g of negative 2. So we look at our graph. When x is negative 2, where do I hit my f graph? At 2. When g is negative 2, where do I hit my g graph? At 1. And so 2 plus 1 equals 3. This right here is saying f of negative 5 times g of negative 5. So when x is negative 5, where is my f graph? Negative 1. When g is negative 5, where's my, when x is negative 5 for my g graph, where's my y value? Now, in order to figure that out, because it's off the graph, let's look at our parabola that's heading down. Notice, I have my vertex and I went over 1, down 1. Then I went over 2, down 4. Over 3 would be down 9. So over 1, down 1, over 2, down 4, over 3, down 9. So 1, 2, 3, 4, 5, 6, and then 3 more, 7, 8, 9. So it's going to be negative 8, which if I multiply those together, I get 8. This is your standard parabola. If you square something, negative 1 squared, we get 1, negative 2 squared, and so on. So now this one means I find g of 0 first. So when x is 0 on the g graph, 1, 2, 3, where am I going to hit it? I'm going to hit it at negative 3. And then when x is x is negative 3, my f graph, where is my y value? 1. And that would be your final answer for that. Now we're going to get into something called the difference quotient. The difference quotient has to do with derivatives, which we're going to be getting into, and it has to deal with slope of a line. But in order to even use that, you need to understand what it means. So a ratio that plays an important role in understanding the rate at which functions change, which is basically a slope of a line, and it has to deal with derivatives. So for this next problem, find the difference quotient for the following functions. So I'm going to take f of x plus h. So instead of putting an x, I'm going to put an x plus h. I'm going to put this in brackets. So I have 6 times x plus h minus, or plus 1. There's my first part. Everywhere I see an x, I put x plus h. Minus f of x, which is my original. 6 plus 1, all over h. Then I'm going to simplify that, and I get 6x plus 6h plus 1 minus 6x minus 1 over h. Those cancel, and you get 6h over h, which equals 6. Basically, this is just saying if I was to graph this, what is the slope of that graph? 6, which we know from right there. Now we're going to go to the next one. So I'm going to do -2 times parentheses x plus h squared plus x plus h plus 5 minus my original all over h, which equals -2 times x squared plus 2xh plus h squared plus, and I don't need the parentheses on that anymore, x plus h plus 5 plus 2x squared minus x minus 5 all over h. Keep simplifying that. I don't need the brackets anymore. -2x squared minus 4xh minus 2h squared plus x plus h plus 5 plus 2x squared minus x minus 5 over h. Now, we should notice that things should cancel out. So, -2x squared, positive 2x squared. X, -8, x. 5, -5. So what I'm left with is -4xh minus 2h squared plus h over h. What do all of those have in common is an h. So I can divide all of them by h, and I get -4x minus 2h plus 1. Now, that's not going to make a lot of sense to you in terms of how that deals with slope until we get to derivatives. And so when we get to derivatives, you'll understand how this deals with slope. So now we go to the bottom. We have, this is what they're giving us as they're telling us what the difference quotient is, and they're asking us what is f of x. So remember, f of x is always what you're minusing. So in this case, f of x is just 3x plus 1. So if you think about that, if I take x plus h, plug it in here, I get that minus my original over h. Same thing here. What am I minusing? X to the third. So if I take x plus h, put it in there, to the third minus my original, divided by h. Next one, what's my original? What am I subtracting? Sorry, it should be f of x. I'm subtracting root 2x minus 5. So if I put an x plus h in here, minus my original divided by h, and every time that's the same pattern that they have. What am I minusing? 1 over x. So if I put an x plus h in there, I get that minus the original divided by h. So these are all dealing with compositions of functions and the difference quotients. Hope you guys are having a good time while I'm gone. I'll see you soon.